Welcome to this presentation on the topic of causality. The outline is as follows. We will explain what is meant by a causal system and causal signal, and we will derive an expression for the output of a causal system to causal signal. If the output of a system depends only on the past inputs, the underlying system is called causal. If the output depends on future inputs, then it is not causal. No man-made system ever is dependent on future input, in which case we say that the system predicts the inputs. For LTI systems, LTI causal systems, we can show that the impulse response is 0 for n less than 0. How do we do that? We argue as follows. Remember, it is an LTI system, so the initial state is 0 and no input comes until n equals 0 because it is an impulse input. Impulse input comes because we are talking about impulse response. It becomes non-zero only from n equals 0. Until then everything is 0, input is 0, initial state is 0, so naturally the system output has to be 0 until that time. So impulse response can begin only from n equals 0. We will next define the causality of a signal. We just define it. We say signal u of n is causal if u of k is equal to 0 for k less than 0. That is, whenever the argument is negative, that u of n is 0. That is defined as a causal signal. This is just a definition. We use such signals frequently in control applications. For example, in control we always say we are at time instant n equals 0. What happens from now? What happens if an input becomes something else from now on? Initially it was 0, it goes to a new value. What happens to the system? We will now derive an expression for the output of causal systems to causal signals. So we consider a causal system and we will consider the sequence u of n, which is causal. That means from n equals 0 onwards it is non-zero. Before that it is 0. This is the general expression that we have seen many times. Now you substitute the fact that u is causal, that is u takes the value from k equals 0 onwards. Okay, before that k is negative and so u of negative value, this will become 0, so we got this. Okay, so I write it here, u of k is equal to 0 for all k less than 0. Can I further improve? Remember, now g is also causal. G is the impulse response of a causal system. So as a result, this needs to go, k needs to go only up to k equals n. If k is greater than n, this argument will become negative and so this whole term will become 0. We do not need to consider those terms. Okay. So I go from k equals 0 to n, and that is because the impulse response is non-zero only for its argument being 0 or greater than 0. That brings us to the end of this brief presentation. Thanks for joining.